In order to add and subtract radical expressions, we have to have like radicals, which are radical expressions that have the same radicand and the same index. For multiplication, we're just going to apply distributive property. So let's go through some examples on how to add and subtract radicals, followed by multiplication. We check our two terms, and we see that square root of 11 and square root of 11, they are the same radical expression. So we apply our distributive property to add the coefficients on these like radicals. We have 4 plus 8 square root of 11, which gives us 12 square root of 11. Again, we're applying the distributive property to essentially factor out the like radical of 11, leaving us with just adding the 4 and the 8. It's a nearly identical process as to combining like terms if I had variables instead. 4x plus 8x is 12x. 4 root 11 plus 8 root 11 is 12 root 11. Same index, same radical, we can go ahead and subtract. 5 minus 7 cube root of 3x gives us negative 2 cube root of 3x. Here we have a mismatch on the indices, so we cannot add. Here we have a mismatch on the radicands. However, we can simplify both of these. So we're going to simplify the radical first. We can split this into 4 and 5. So we end up getting 2 square root of 5. And this we can split into 9 and 5. So we end up getting 2 times 3 root 5, which gives us 6 root 5. Now we do actually have like radicals, so we can add the coefficients in front, giving us 8 square root of 5. We have 3 radicals to simplify here. Cube root of 54. We can split this into 27 and 2. So the cube root of 27 is 3, cube root of 2. 16 we can split into 8 and 2, 5 times 2 cube root of 2. And this is already simplified. So when we simplify a little bit more, we see that we have like radicals on every term. So we can go ahead and do 3 minus 10 plus 1 cube root of 2, giving us negative 6 cube root of 2. So we'd look to see if we can simplify these at all. 27 we can split into 9 and 3, giving us 3 square root of 3x, minus, we can split this, we can take the square root of 9, and here we have 36 and 2 and x, leaving us with 6 root 2x. All of these are simplified, but we cannot simplify any further. These are not like radicands, so we can't add them up. Here we've got a mismatch on the indices, so we know we won't be able to add them, but we do want to simplify where we can. Since I can simplify the square root of 98 as 49 and 2, we can reduce this to the cube root of 98 plus 7 square root of 2. We have cube roots, so we can possibly add these. We just want to simplify first to check. 48, we can rewrite as 8 and 6. Y to the 4th will become y to the 3rd and y. 6, we can't split and get a cube root, but we can with y to the 4th make it y to the 3rd and y. So now we'll have 2y cube root of 6y plus y cube root of 6y And since we have like radicands now, we can go ahead and add their leading coefficients. 2y plus y equals 3y cube root of 6y. In order to subtract these fractions, we need a common denominator, but let's go ahead and simplify our any radicals first. 45 is 9 and 5, so we get 3 root 5 minus root 5 over 4 and 3 respectively. In order to get our common denominator of 12, we'll multiply both of these fractions by an expression of 1, giving us 9 root 5 over 12 minus 4 root 5 over 12. And now we can go ahead and subtract our numerators. 9 minus 4 root 5 over 12, giving us 5 root 5 over 12. Here again, let's simplify any radicals that we can. We can take the cube root of 8, so we end up with cube root of 7x over 2 plus 2 cube root of 7x. Well, in order to add these, we need a common denominator, so we'll multiply this fraction by 2. 3 cube root 7x plus 4 cube root 7x over the common denominator of 2, giving us 7 cube root 7x over 2.